Hi, my name is Joey with the Garmin Aviation team, and for some time now, flight displays and navigators have been a staple in Citation aircraft. And behind me, we've got our Citation CJ2 with our very comprehensive upgrade package that not only includes our G600 TXI flight displays, GTN 750XI navigators, also includes our engine indication system, GFC 600, options for our GWX 8000 weather radar, modern connectivity with GDL60, PlaneSync technology, and much more. All this together brings really exciting, unique, integrated benefits when you put everything together. Let's go inside and have a look. I'd like to give you a little overview of all of the avionics that are installed in this upgrade here. And we'll start right here in the center, which is really the brains of the flight deck, our FMS, and the really familiar GTN 750XI navigators that has our GPS navigation, our VHF nav radios, as well as our comm radios built right into them. And in this top GTN number 1, we've got our audio panel built in behind the scenes, and it can be controlled right up here between mic selection, as well as your intercom has a really intuitive selection to help talk with the co-pilot and or passengers if you've got passengers, headset wired, and then select sources of entertainment here below. Likewise, we've got the remote transponder built in here. So we've got transponder 1 and 2 behind the scenes, obviously, and set those as needed for the flight. So we'll move down here to the GFC 600. Based on the acclaimed performance of the GFC 700, it's an awesome autopilot and just flies the airplane with great precision like you're flying on rails. It's awesome. So you get pitch trim, roll and yaw, axes are all covered. 4 servos are driving this amazing autopilot. We've updated the display to align with the PFD and the G600 TXI flight display, so those scoreboards now match identically. So it just makes it for a really intuitive experience and integrated experience between the two. Moving up from the autopilot, we're going to talk about our engine indication system. So we've taken out all of the engine indication systems previous and installed this single display to support that. And all of those existing sensors are all coming into our system now. So those all stay, but come into our engine analyzer and then displayed on our display here. So that's what you're seeing. It's got a built-in in-one computer we talked about during initialization. You can see when it's magenta up here with a Q, it's automatically calculating your in-one computer based on the outside air temperature of the aircraft. And that's available for takeoff, maximum continuous thrust, the go-around mode, and considers anti-ice status. So that's a quick overview of our engine indication display. Moving here right in front of the pilot is our 10.6-inch G600 TXI flight display. Now, we've recently introduced a larger format 12.1-inch flight display, which makes everything just scaled up. So it's larger font sizes, larger numbers, easier to read, etc. So this is displaying all of our primary instruments. So we've got our altimeter, airspeed, HSI, attitude indicator, of course, as well as our autopilot modes, turning rate indicator, etc. So that's our G600 TXI flight display. Also, it has a multifunction display to display other information there as needed throughout the flight. Moving here to the left of the primary flight display is our standby GI-275. So this is an all-in-one attitude, altimeter, and airspeed, as well as heading indicator. So it contains its own air data computer and attitude and heading reference system, as well as a approximately 1-hour battery, all self-contained on its own. So if you lost all power, including the emergency bus, this GI-275 will stand up. And what's awesome is that it's integrated. So when you adjust the baro here or anywhere else in the system, it's adjusting it on the TXI. There's no baro dance required where you're entering baro in multiple places. This is an integrated system. It goes across everywhere. And then to the left of the GI-275 is our GSB USB ports for Type A and Type C, and we make them in a couple different configurations depending on your preferences for Type C, dual Type C, or dual Type A. So coming down here just below the throttles is our GCU 485 PFD controller. This allows the pilot dedicated controls for inputs into the PFD to select new altitudes, heading, vertical speed, adjust your CDI, or transfer the source of what the autopilot's tracking between the sensors, between the pilot's primary flight display and the co-pilot's primary flight display. And so what's really intuitive about the GCU 485 is if you look at the unique texture and controls on each of the knobs, you can really get a tactile memory feel for each of those to manipulate and enter in a new altitude and heading with pretty good precision there without having to glance down so much. So that's the GCU 485 PFD controller. So that's really an overview of everything that's inside, visible here to us in the panel. Now we want to take a little look at some of the things and options that are, some of the avionics and options rather, that are behind the panel. Let's have a look. Let's talk a little bit about some of the upgrade options available to us that are behind the scenes. So we'll use the GTN 750Xi as kind of our guide with some of the multifunction display options here, and we'll start right here with our traffic display. So a couple different options for our traffic. We've got the GTS 825 active traffic system, which gives you about 40 to 45 nautical miles of interrogation range where it's actively interrogating other traffic. The GTS 855 is a certified TCAS 1 system with 80 nautical miles of interrogation range, so depending on your preferences. When you combine that active traffic system with our ADS-B GTX 345 enabled transponder, you get the best of both ADS-BN and active traffic system with correlation. So it's always going to give you the best traffic available from the best source, which is amazing. We've got great technology built in here. So you've got these brown chevron targets here that are active targets right now as we speak, taxiing along the airport route here on our safe taxi display. We're just zoomed in really tight. Then we can zoom out and you'll see chevrons of the aircraft that are flying around our area overhead as we're sitting here on the ground talking to you right now. What you're not seeing here, what you'll see in the air is our target trend technology, which is really amazing. So it will take your aircraft's position of velocity into account of the other aircraft's position of velocity and let you know where your paths might cross. So that's our target trend technology. It's only available from Garmin. It's really amazing tech. So that's some of our active traffic as well as our ADS-B traffic options. We've got our terrain solution. So with the base package is TAWS-B, and that gives you a 500-foot call out as well as some algorithms for the terrain. TAWS-A takes it a step up and adds some additional call outs as well as integration to consider your flaps and gear inputs as well. So the TAWS-A adds those additional call outs. You can see there we've got 500, that's part of TAWS-B, that's always on. But you can also select call outs from 400 feet down to 10 feet based on your preferences. So in this case, we've got a call out at 500, and I've selected 200 feet here to meet the CJP Citation Jet pilots SOPs in this case. So a nice handy reminder there. That's exclusive to TAWS-A to get those additional altitude voice call outs. We'll look at our weather options here. So we've got several different options here. Starting in the top left-hand corner with SiriusXM data link weather, so you can access high resolution next rad imagery, updates really fast. To the right of that, you've got your THIS-B weather that's based on our ADS-BN technology from our GTX 345 transponder. So you'll get that as another next rad weather source. And then the bottom left-hand corner, we've got our Connects weather. And so if you're traveling outside of the US, this is a great data link weather solution for you to keep in addition to your primarily North American sources with SiriusXM and really your US sources with THIS-B. So Connects weather can help you augment all those other NextRad sources as well as METARs and TAFs, etc. You got varying coverage depending on where you're flying. Pretty comprehensive coverage here in North America and in Europe and some other areas for NextRad, and then worldwide TAFs and METARs available. And then the bottom right-hand corners are weather radar. That's our GWX 8000 weather radar, and pilots absolutely love the GWX 8000 weather radar for its automatic mode capability. So basically, you just turn on the radar, and it automatically adjusts the gains and tilts and presents a high-fidelity picture of the precipitation in front of the aircraft back to the pilot. And it's really good, and we've gotten terrific feedback and accolades from the community on our GWX 8000 weather radar tech. So moving on from our weather products, we've got our some of our services that complement the GSR56 Iridium data link. We talked about its weather products. Well, also offers the ability to make and receive phone calls through your headsets in the flight deck, and then the ability to send and receive text messages, and then you can also send that text message as an email. And then if you've got the GDL69 data link, accessing the in-flight music entertainment option there as well. So moving over here to system, we've got our connects set up there, and this is where we're going to connect our GDL60 data link, which does a handful of different things, but one of those is it replaces what we used to have here as a FlightStream 510 for our in-flight connectivity with our portable electronic devices, or our PEDs. So you can access apps like Garmin Pilot and keep everything in sync between our avionics and your iPad app. So that's just a brief of GDL60, at least as it relates to the connectivity between the iPad and your avionics. And last but not least is the ATC data link here, which is our CPDLC US domestic FA datacom. This is really the modern way that we're communicating now between air traffic control and pilots. And so voice messages can become inefficient, particularly when you're given a new route clearance. You've got to read back each of the fixes, and there can be opportunities for miscommunication. But this takes really all that out of it. Get your new route, you get to view that route, accept it, and automatically input it in the flight. You can get different center handoffs and automatically upload the frequencies of the next center to your active radio automatically. And likewise, if you get a new altitude, you can automatically input the altitude into your altitude select with what they've given you. So it's really tightly integrated with this solution as well. So moving over here to the primary flight display, just a couple things, indications we'll point out. So we'll interface with some existing distance measuring equipment, DME. Garmin's got our own DME, GDM 450R, so you can display distance to a DME. And then we've got a radar altimeter, our GRA 55, that can optionally be displayed on the flight display as well. So that's just a quick overview of some of the options that are behind the scenes in this upgrade package. So we've just booted up the system, and the system's prompting us for three key inputs. The first input is initializes the N1 computer. So we've replaced the existing N1 computer that's in the aircraft. It's effectively putting all of the tables in the aircraft so that you don't have to go reference another sheet or compute the appropriate N1 speed at the appropriate temperature. So it's all built in here, and that'll display up here with the appropriate value for takeoff. Max continuous thrust also considers NIS status. So we'll initialize that with outside air temperature. It senses automatically from the outside air temperature probe. So right now on the ramp, it's 24 degrees. And so we'll hit continue there. The second entry point here is to initialize the fuel computer. So fuel computer is calculating and estimating our fuel, which is a good comparison against our fuel gauges along the flight. And the other really nice benefit of the fuel computer is the display of that graphically on the moving map displays with a fuel range ring. It'll show you the fuel range to IFR reserves or to fuel exhaustion. So you can see exactly how much fuel you have on board and where you can fly geographically before you hit your IFR reserves. So we'll initialize that there. It gives you the ability to sync right from gauges. So in this case, those two align. So we've got just under 1,200 pounds of fuel. You can touch the sync from gauges and enter, and that initializes that. If you want to, you can add your fuel weight, and that will just also decrements. As you decrease fuel, it will estimate your total weight along the way. So we can just add our previous 8790 pounds there. The third key value that we want to enter is initialize and post our speed bugs. So we've got all the V speeds here defaulted to simplified criteria. So if you are eligible for that, you can simply hit all on or adjust each of those individually as you need. And we've selected with all on the ability to have audible call out. So as we pass through those speeds, you'll get an audible call out for V1 and V2, etc.
V1, rotate. V2.
All right, so the Garmin engine indication system leverages all the existing sensors in the aircraft into our engine analyzer, and then they're displayed here on this dedicated 7-inch display. And just working through the indications, you got your N1 displayed with the target torque from our N1 computer. So that little magenta caret is the tick mark displayed at the top, calculated by the temperature and the book values. ITT, we'll come back to that in just a moment, into fuel flow, oil pressure, oil temperature. You got your fuel quantity and total, as well as your fuel temperature, your outside air temperatures, RAT and SAT, and then your ISA calculated. And then around the bottom here, you've got your pilot selectable data fields for the fuel calculator itself. Now, coming back up to your ITT, this is a dynamic gauge, so at startup it will support the indication range based on that starting event. You'll notice the start timer become green. Once that starts, you'll get a countdown timer for start. Once you've reached the temperature for your particular CJ, and the CJ2 it happens to be 805 degrees, it will begin a countdown timer for you to help respect that particular limit. And then once ITT comes back within range, the gauge automatically adjusts to accommodate the normal operating range of ITT. The system also has advanced exceedance timers built into them, so should any one of the parameters experience an exceedance, the system's going to begin a timer for that particular exceedance to let you know that it's out of range. It'll flash at you, it'll get your attention, and if that time limit expires, it'll log all that into an exceedance log for you to review later with your maintenance provider. All of this information is being logged at once per second, along with really all the flight data in the aircraft, including the exceedances, the engine cycles, and flight cycle times, all to either an SD card, or if you option up for the GDL60 data link with our PlaneSync technology, all that's offloaded at the end of each flight to the Garmin cloud, and that can be shared with maintenance partners like Flysto and others to help you analyze your flight data information. To look at an exceedance, you can select menu, system, and then logs, and exceedances, and any exceedances that you may have had occur will apply there, and it gives you really rich details about the particular event so that you can understand all the different parameters that went into that particular exceedance, and then help make the right decision with your maintenance provider. So that's just a little bit of an overview of our engine indication system. So one of the things the team worked really hard on and was pretty proud of was the avionics that stay alive should you have to use the emergency bus or the EMER bus in the Citation. And so when that happens, we'll simulate that. I'll simply turn off this EIS display here, and that also doubles as should you lose this display for some reason. All that information is going to simply come over to your primary flight display. So you'll have all your EIS indications right in front of you, and then you'll also have your ADAHRs, so your air data, attitude and heading reference system, and then your primary flight display indication. So that all of that PFD would stay available just as it's pictured here. And then you'll continue to have your GI-275 here standby. And remember, beyond the EMER bus itself, this has got its own backup battery that lasts just about an hour, so you'll continue to have your GI-275. You'll have your number one GTN 750XI, as well as your audio panel, so you can retain, navigation and your communications with ATC as well during the event. Really terrific capability, a lot of information that you'll have, and should you have to use the EMER bus for any reason during your flight. So Garmin made a significant investment to interface with several existing systems and options on the aircraft. Things like your AOA computer, interface with your stall system, gear, flaps, indication to help feed some of our TAWS features, etc., as well as your speed cues and more. So those are all available to you. And then there are some existing avionics that we interface with as well that you can work with either a Textron Service Center or a Garmin Aviation dealer to understand what options you have in the aircraft. Today is regarding traffic or weather radar systems that may be compatible with our system now to help you more economically step into the upgrade if you chose to do that, or make a decision to upgrade with the Garmin options we discussed in the aircraft. So for our aircraft, when you consider removal of all the existing incumbent equipment, you think the displays, the servos, all the wiring, and putting in all this modern, more updated technology, lighter weight, we saved about 85 pounds on this upgrade. Now, we did have to ballast about 30 pounds in the nose to make our CG work overall. But just to give you an idea about the overall upgrade picture and some of the options for you to consider. So the GFC 600 follows in the footsteps of the acclaimed GFC 700 Autopilot. Its performance is simply amazing. Really shows it and demonstrates its performance with how integrated this system is between the navigators and flight displays throughout the arrival, the approach, and your missed approach, really simplifying a otherwise high workload situation and event. Part of that is the tight integration in the architecture that we designed for this aircraft, where each flight display has its own set of sensors, and it also has a set of sensors for the GI-275. So the system is constantly monitoring between the different sensors and will remove any sensors that aren't performing as they should. The pilot can also select between sensors on the primary flight display by selecting sensors and move between pilot's PFD, the co-pilot's PFD, and the standby sensors there, and just simply select between those manually if you have a preference there. All the while, your GFC 600 will continue to operate between these different sensors and sets. Now, to switch between which set of sensors is driving the GFC 600, you can go to the GCU 485 mode controller, and it's the transfer key. So right now on the PFD, you've got a little arrow that points to the left, indicating the sensors from the pilot's PFD are driving your GFC 600. By selecting the transfer key, you're moving the selected sensors to what's being displayed and selected on the co-pilot's PFD. One of the best ways to demonstrate the performance and the integration of the GFC 600 Autopilot is with a arrival approach and then a missed approach. And I've got a flight plan loaded up here from Scottsdale down to San Diego, and the Top Gun arrival loaded in, just to give you an idea how the GTNs are interacting with the GFC 600 here. You've got all of the approach constraints that are published for that particular arrival, as well as your speed constraints. And so not only are those listed there in the flight plan, those are also available and displayed as part of the moving map display for additional situational awareness, both the altitude constraints as well as any speed constraints that are required. So really handy references there. And then coupling the autopilot for descent, vertical navigation, the system will draw a perfect line throughout all these constraints to make sure that you're meeting all those expectations on the arrival and approach that way. When you're shooting an ILS approach, you're going to move through the arrival using GPS, and then the system's going to automatically switch the CDI at the appropriate moment for the ILS procedure. And during your approach, you'll also have, not necessarily a feature of the GFC 600, you'll also have our stabilized approach as part of the TXI feature and benefits, and that's going to monitor your aircraft beginning 1,000 feet from the runway, and audibly and visibly gives you an alert of any deviations from airspeed, baro, or the course, either vertically or laterally, as well as any awareness with a crosswind or a tailwind that might upset your otherwise stabilized approach. And then you've got the ability to set with TAS additional callouts for 500 foot and 200 feet, again, to have some audible awareness for position on the approach for standard operating procedures, SOPs you may have. The system is really integrated with the missed approach. So should you have to go missed, you press the missed approach key on the throttle, and this does several things. The first thing it's going to do is, if the autopilot's engaged, it's going to remain engaged. The flight director command bars will come up 7 degrees for pitch. The N1 computer is going to indicate the missed approach based on the outside air temperature to give you a good power setting to bring the power in. It will arm the selected altitude on the TXI flight display. So if you've already got that programmed in for your missed approach altitude, it'll arm that selected altitude for you. It sequences the GTN 750XI to the missed approach procedure. And for an ILS procedure, it's going to automatically switch your CDI back from ILS to your Magenta GPS CDI. And then once you've completed all your missed approach instructions altitude-wise, you can simply select nav on your autopilot to follow the missed approach procedure in the GTN. It makes a really complex event really simple. So the GFC 600 has several safety features and benefits built into it. The first we'll talk about is while the autopilot is engaged and
Airspeed.
while the autopilot is armed. So while you're flying on autopilot, it has both underspeed protection and overspeed protection. Now, underspeed protection will help if you level off during a descent and you are slow to add or bring in power. So it will lower the nose to help prevent a stall about 2 knots from the stick shaker, and it's monitoring the trend and adjusting those factors accordingly. But it's going to help in those events, and that's how we're able to also provide an autopilot coupled missed approach in that event, that the pilot slow to get power back into the aircraft. Overspeed protection is going to engage and pitch the nose up once VMO is reached, so to help prevent an exceedance on the airspeed while the autopilot is coupled and you're commanding the autopilot. Now, electronic stability and protection, or ESP technology, is there to help while the autopilot is not engaged while you're hand flying the aircraft. And it provides a tactile cue for the pilot when you're outside of the normal envelope of the aircraft. When pitch exceeds either 20 degrees up or 17 degrees down, or your left and right roll is 45 degrees, it's going to provide a tactile cue to the pilot in the controls with the servos riding the aircraft, so that you'll get a cue and a feeling that you're outside the envelope. Now, we understand that obviously there's training maneuvers, steep turns, etc., where you may be in some of those attitudes, and that's why we designed ESP to be disabled for those types of events. You can do it through the mode controller or just press and hold the autopilot disconnect for so many seconds, and it will automatically disarm electronic stability and protection technology. Now, level mode, the blue level mode button, will help just right the aircraft in zero pitch and roll. So just a level attitude of the aircraft. This can help if you become disoriented. If there's so much time in ESP mode, it will make an assumption that the pilot needs a little help and can automatically engage level mode to level the aircraft in a zero pitch and roll attitude to help reorient and resituate the aircraft. Now, emergency descent mode helps protect during an unplanned depressurization event, and it automatically arms the aircraft above 15,000 feet. There's a pressure sensor built into the aircraft to detect cabin altitude, and if it detects a cabin pressurization below 12,500 feet, will automatically activate emergency descent mode, descending the aircraft at 10 knots from the VMO speed down to 15,000 feet, and turns the aircraft to the left to help alert ATC of an EDM event. Finally, we've got our low bake mode, really for passenger comfort as part of normal operations. That limits the roll of the aircraft to 15 degrees above flight level 240, where it automatically engages, or can be engaged at any time based on your preferences, just to help with the comfort of the passengers when you're making those turns. So that's just a little bit about the GFC 600 overall and some of the safety benefits that it offers. One of the upgrade options available from Garmin is the GDBX 75 or the GDBX 8000 weather radar. Now, just to begin, both those radars are modern solid-state technology that replace magnetron-based legacy technology that wears over time. So that helps with the cost of ownership longer term, just by virtue of the technology. Think, a spinning disk drive versus a solid-state hard drive. Now, the technology displayed to the pilot is improved quite a bit as well. With that, we're used to a 4 or 5 color display to help us understand between precipitation intensity. Now we've got 16 colors to really help better understand that. Now, this is a 120-degree scan weather radar, so you've got a good view around the aircraft. The other unique benefit and integrated benefit with our GWX 75 and 8000 weather radars is that they can be displayed on all 4 of your MFDs that are in the aircraft, and they can each be displayed with its own unique position. So if you wanted to leave one at a specific range and tilt, as well as horizontal, you can set one up that way on a different display. You can set one for a vertical scan with a different range, so you can have a couple different views of that weather in front of you. Now, that's largely in the 75 as well as the 8000. What the 8000 brings is we've leveraged that technology that's in most of the airliners flying today with automatic mode, and we've scaled that down for all of us to enjoy now with the ability to just turn it on. It is always scanning and presenting the pilot with the precipitation intensity in front of the aircraft. So no gain or tilt settings are required in automatic mode. Those also come really fully feature rich with ground clutter suppression, turbulence detection, and lightning and hail prediction as well. So that's just a little bit about the option for the GWX 75 and 8000 weather radar. One of the popular options for the citation upgrades is the GDL60 data link with our PlaneSync technology. And so that really does 4 things for us. The first is it connects our portable electronic devices like an iPad or iPhone with our favorite electronic flight bag EFB apps like Garmin Pilot to the Avionics. You'll get remote aircraft status, automatic database downloading, and automatic flight log uploading. So we'll start here with our iPad, and we're just synced up with all of the data link information that we're equipped with. So we've got our ADS-B in technology with our traffic. We've got weather products, so you can look at the traffic here on the ramp here at Scottsdale, and that mirrors what we're seeing on our avionics. With our target trend technology, they're just taking off runway 21. We'll zoom out, and you can see next rad across the country up in the northeast, some snow and some precipitation systems moving through there. So all that information is syncing on our iPad. And then we also have the ability to, we're doing our flight planning at home and we want to upload those complex routes that we've already figured out to our avionics. So you can quickly do that. I've got a route here from Scottsdale back home to New Century with a departure out of Scottsdale and a arrival back home. And so we can click the wireless icon on the just next to the status bar of the flight plan and select send to, and that says sent. We'll move up here to our GTN 750XI, and you'll see the flashing message indicator at the bottom of the display, noting that there's a transfer. So we'll select that, and it has one new flight plan waiting for us. And we'll look at that. We can preview that to make sure all that is accurate. Look at the map, just double check everything, and you can choose to activate that, and it just double checks we want to do that and override our existing flight plan, which we do. Looking at some of the other benefits of the GDL60 data link is our automatic database uploading. The system is equipped with its own battery, so if you disconnect the main ship aircraft battery at the end of your flight, that's no problem. You can optionally install a secondary battery that just supports the system, and what it does is it will wake up at a pre-programmed time, early in the morning, at the availability of the next cycle database, and download that database automatically to the GDL60 hard drive, and then shut the system off. Once you step to the aircraft is going to look to the GDL60 just like it did your SD card for that database update, and it's going to stream the databases automatically to all of the displays in the flight deck at 100 megabits per second. And you'll see the system status page accordingly with the active and any standby databases accordingly. And you can track that with the database sync tab as well. We also have the ability while you're away from the aircraft with our PlaneSync remote aircraft status via Garmin Pilot, or some of our watches can even do this, our D2 series. Wake up the aircraft, and that's going to wake up the engine indication system and will refresh all of the gauges, like your fuel gauges, outside air temperature gauges, and shut down the aircraft. And then it's going to provide all that information to you in real time, so you can understand if you've been moved into a hangar, what the temperature of the aircraft is. You can understand if your aircraft has been fueled to your preferred order. And the fourth and final capability is our automatic flight data log offloading. So the engine indication and the system at large is capturing flight data information every second from the aircraft and recording that information. It can record that on an SD card. It's been doing that for some time now. And now the GDL60 is recording that data. And at the end of that flight is automatically going to share that with a Fly Garmin cloud for you to go to review on our website. So that data will just be there waiting for you. You can review it later. You can also choose to connect any one of our approved partners, like Flysto, for example, to do a post-flight debrief if you want to see, how your approach looked and how stabilized you were, etc. You can do that from Flysto. So with GDL60, you've got the ability to connect your portable electronic devices. You've got automatic database downloading, remote aircraft status to wake up the aircraft, understand the status, and the ability to automatically upload your flight data logs. Look at those with some of our partners as well. those are some of the benefits with the GDL60 and our PlaneSync service. Let's talk about Garmin guided visuals. For almost a decade, Garmin has provided visual approaches. So that's based on our FMS, the ability to load an approach to most any airport in our database that has a published runway in it. And this provides us really simple 3-degree glide path from the runway endpoint up to a 3 nautical mile waypoint. While that covers a lot of airports, what it is challenged with is airport environments that have unique challenges in terrain, obstacles, and or airspace that surround them. And so Garmin's latest solution to that is a partnership with Hughes Aerospace to help us chart and navigate these specific airports that have these unique challenges. Just to show this off for you here, we've got right now an arrival into Scottsdale Airport from the north, so that we've got the Desert 2 arrival loaded up here. We're trying to think about how we're going to transition into the terminal environment, specifically where there's some mountainous terrain just to the north of runway 21, which is the favored runway for landing. So we'll load first the normal visual approach just to show you what that looks like. So again, runway 21's the endpoint. It publishes 3 nautical miles. We can zoom in here and just get a little bit of a pictorial. You see the terrain starting to rise right on that 3 nautical mile waypoint. And so Garmin guided visuals helps take this specific terrain consideration into account and publishes specific waypoints with altitude constraints that can be completely coupled with your autopilot to fly a smooth, continuous, stabilized approach into the terminal, into the runway. And so let's take a look at the same approach here, which is noted as the Gulf or G approach, runway 21. And we've got vectors as a transition. You can see all the various transitions available. YOLO is one of them, and that just happens to be one of the final fixes on the Desert 2 arrival. So we'll choose the YOLO to transition into this Garmin guided visual a little more seamlessly. So you can see YOLO, and then we've got some waypoints that we created just as a part of this design. You can see the altitude constraints published at each one of those waypoints. We can use our VNAV capability to command the aircraft to meet each of these constraints, and a smooth, continuous, and stabilized descent down to the runway environment. So in addition to having everything programmed in right into the FMS, just like you would a normal approach into the airport environment, we'll transition over here to the flight display to show you what this chart looks like. So you've got published flight chart, Garmin flight chart for this, and you can see the YOLO transition, the altitude constraints available at each of those waypoints, and the transition into the runway environment here. It also has a profile depicted, and in this case, we're going to be a little bit steeper than a normal 3-degree glide path. We'll be at a 4-degree glide path into from the final fix here at SDL01 down to the runway endpoint, runway 21. So Garmin guided visuals are available exclusively from the Garmin navigation database. They're packaged with our Garmin flight charts into a bundle we call a Garmin One Pack, available for you to take advantage of these specific approach. We've got 31 approaches published today at 25 different airport locations to help with these, and we are continuously working with Hughes to identify additional airports that have these challenges in place and provide additional guidance. So we're growing this database as well. So that's a little bit about Garmin guided visuals. I hope you're as excited as we are about all these new upgrade options available. TXI flight displays with engine indication system, dual GTN 750Xi, the acclaimed GFC 600 autopilot, and many more options. This is now available for the CJ2, the CJ1, and soon the original Citation jet, with more models to follow. For more information, visit us online. Thanks for watching.